Next, it's my honor to welcome Dr. Pete Parker from NASA Langley Research Center to present the NASA Technical Keynote Address. Dr. Parker is team lead for Advanced Measurement Systems. He serves as an agency-wide statistical expert and infuses statistical thinking, engineering, and methods, including statistical design of experiments, response surface methodology, and measurement system characterization. Dr. Parker was a co-founder, along with Dr. Laura Freeman, of this workshop. The idea grew out of the 2011 NASA Statistical Engineering Symposium that enjoyed strong participation from the operational test and evaluation community. Subsequently, when Laura and Pete developed the Interagency Statistical Engineering Agreement between NASA and DOT&E, they made this workshop a centerpiece element. Dr. Parker served as NASA co-chair in 2016 and 2017. Dr. Parker currently chairs the American Society for Quality's Publication Management Board and previously served as editor-in-chief of the journal Quality Engineering. He holds the following degrees from Virginia Tech: a BS in Mechanical Engineering, an MS in Applied Physics and Computer Science, and an MS and PhD in Statistics. On a personal note, Pete has served as a valued mentor to a number of researchers and engineers. Please join me in welcoming Dr. Pete Parker.
Well, good morning. Everybody hear me okay? Great. Well, I'm certainly honored to be here, and I appreciate this opportunity to talk to you all this morning. I particularly want to take a moment and thank the organizers of this meeting that I think have put together a fantastic program. The short courses yesterday and the program that's going to be in the next 2 days, and so it's just really impressive. So you see my title slide, Highly Effective Statistical Collaboration. This is really going to be a talk about interdisciplinary collaboration, but I'm going to add sort of a statistical perspective to that, some of the challenges that we as statisticians or statistical practitioners, and I'm going to use those terms interchangeably. I know there's a lot of people here that may not identify as a statistician, and that's okay. I'm personally, you heard my degrees, my undergraduate degrees in engineering. So when I use the term statistician, just think of somebody who's practicing statistics. You know, I've looked back over my career, and I have known great collaborators. I've had the opportunity to work with them, and I've seen the benefits. And I've been told that I'm a very good collaborator. But several years ago, I was sort of challenged that I don't really know how to teach collaboration very well. I don't know what the right combination of factors are, if we think of this as a designed experiment, to achieve good collaboration. You know, which factors matter, which do not, and which ones increase our likelihood of success. And what I really wanted to do was collect ideas on what works, but beyond that, I wanted to know why it works. I wanted to go into the literature largely outside of statistics about what are the methods, what are the fundamental constructs below these methods that work. Hopefully today I'm going to encourage you, motivate you to be a better collaborator, and my takeaway is that we can all become better collaborators. I think I'm going to try clicking this again. Let's try this again. All right. Let's try that again. I won't have to keep moving it back and forth. All right. Now on to the next technology here, slide advancement. Great. Okay, so a few acknowledgements. This is a talk about collaboration, and I've got some great collaborators. The first one, Mike Latano, was a student that I enjoyed working with at NASA Langley several years ago. He was a PhD student in industrial organizational psychology, and we brought him on to do a variety of projects, but one of those was multidisciplinary teams that were geographically dispersed. What are the techniques we can use to make those effective? In addition, Willis Jensen and Jennifer Van Mullicum and I did a panel session about a year ago. Well, it wasn't that quite, last October, and it was on collaboration. And so we had an industry from Gore, we had academia from Virginia Tech, and we had myself from government talking about the benefits within organizational collaboration. And then Christine Anderson-Cook, who many of you might remember of 2 years ago, gave the keynote here at this workshop on decision making. She's at Los Alamos, and Lulu, who's a professor at University of South Florida, we're currently putting together a paper about to be submitted. That's what we always say about a paper that's drug on too long. About to be submitted on interdisciplinary collaboration. So what I'm presenting today is really a culmination of a culmination and compilation of many different contributions through many different colleagues. And so if you hear something today that was your idea, take that as a compliment. I've heard it said that the definition of originality means you forgot the source. And so I got no pride and ownership what I'm presenting today. So let's go on. So this is a statistical engineering keynote, and statistical engineering, you might ask, well, what's the motivation for it? Why statistical engineering would be another way to put that up. It's a discipline that engineers fundamental statistical sciences and integrates those with other disciplines to solve complex and high-impact challenges. That's the only definition I'm going to give you today of statistical engineering, but I would say that that definition is most appropriate to most of the audience here. We are working on national defense, we're working on advancing aeronautics, as we just heard from Bob Pierce, studying the atmosphere, exploring the universe, both manned and unmanned. These are some of the most challenging and complex problems we have to work on. And we want to have greater impact and influence on those projects. We want to avoid huge mistakes. And some of you probably have experienced that in terms of the consequences of huge mistakes. And I'm going to suggest that we can and must do better in our ability to influence those projects. Because we have more to offer, but also because those projects are becoming increasingly complex, where they can't be solved by a single discipline. It will require interdisciplinary collaboration. So how do we do this? I've painted a really lofty goal, right? There are many different components that obviously have to come together. This workshop is one of them. Training in statistical methods and tools is absolutely essential, and this is a fantastic opportunity to do that. But I'm going to argue that it takes more. It takes more than knowledge and competence in statistical tools to have impact. It takes effective collaboration. Competence in statistical tools is necessary, but not sufficient. And even with the best preparation and methods and tools, if you're not in the right place, when I say place, I mean relationship within your organization, respect, be at the right tables, then you're not going to be able to use those tools and have impact. And so last year's keynote, Jeff Vining talked about the theory of statistical engineering. And just as a side note, there's a significant effort outside of this group, but will be inclusive of this group, to develop the theory and the discipline of statistical engineering. So look for more of that in the coming year. But one key element of Jeff's talk was interdisciplinary collaboration. And so that's what I'm going to focus on today. When I look back over my career, I've surveyed various traits to be a successful collaborator. And I've also surveyed various disasters in collaboration. And regrettably, I've been part of some of those. But this keynote's going to be positive. We could give a similar one on 100 things not to do. If you want that complimentary talk some other time in the future, we can do that. But I'll give a few things not to do today, but we're going to be positive. And I hope that throughout the talk today I'll give you a broader perspective on collaboration, maybe a bit of a self-examination, a self-evaluation of what you can do better. To many of you, what I talk about today may seem obvious to be a good collaborator, and that's great. And if it's obvious to you, then what I would challenge you to take away is, can you articulate the ways in which you achieve successful collaboration? So hopefully I can help you in that way. As a bit of a disclaimer, this is going to be somewhat of a soft talk. I'm not going to have any Greek. You'll have plenty of that in the next 2 days on PowerPoint Greek. Hopefully you're not going to think I'm speaking Greek, but we're going to talk about collaboration. So these are the key elements or takeaways that I'd like you to get from my talk. First, I'd like to be able to distinguish what I mean by collaboration and differentiate that from other types of teamwork. I want to motivate you to collaborate, to be a better collaborator, and talk about the benefits. And I'm going to talk about the challenges that are specific to statistical practice. The subtitle of the talk was The Art and the Science, and the way I've constructed that is I'm going to give some examples today, 3 main sort of examples from my experience, and that's a little bit of the art, and then I'm going to talk about what's in the literature, largely outside of statistics literature, and the science behind that, or the research behind that. As I've said, I've had the opportunity to work with great collaborators, and I've been blessed to be able to be on high influence projects at NASA, and those have been really exciting and thrilling times. It's incredibly satisfying feeling to see the impact that you can have on a high impact project like that. But I'm going to tell you, I don't think those opportunities were all due to luck. And in fact, I don't believe in luck. And if you want to come up later, you can ask me why a coin flip is not random chance. But you might hear that as funny coming from a statistician. I want to share those lessons learned, and I've analyzed and retrospectively looked back a lot of those, and hopefully help you prevent a few mistakes and give you some positive things to work on. So let me talk about what I call a spectrum of teamwork. The first is when somebody comes into your office and they bring a problem that's part of a larger problem, and they're asking for your advice or your consultation. You're not really part of that team, and when you give them that answer, they go away and they have their solution. Now, in some cases, that person has been sent to you. That's a bad situation. But you just provide that answer, it's a consultation, and you move on. That's on one end of the spectrum of teamwork. The next would be dividing a task among multiple disciplines or team members. And I'm going to refer to that as simply cooperation. You're on a team, you might be working toward the larger problem, but you're working in your cubicle, in a sense. You don't really need to have a lot of real-time collaboration, which obviously is the term I'm going to get to next. You can solve your problem, pass it on, input, output, kind of producer-consumer relationships. Finally, collaboration, which is a higher level of mutual engagement. In this, I distinguish it from the fact that we're working toward common goals to solve a problem together. Nobody's assigned to collaborate. You can be assigned to serve on a team, but collaboration is a proactive process. It requires proactive components on your part to integrate into that team. You're part of the problem definition. You're identifying the problem and solving it together. And so in that way, you have a common goal. So one of my simple tests to determine when a statistical practitioner talks to me about their work as to where they are in the spectrum is I listen to their level of whining. If they're whining that the team is not using their methods, not listening to them, then I realize they're really not collaborators. Because if you're on a team, it means that your idea will not always be accepted, but you will support the team decision of what the path forward is. And so there's a little self-examination for you. So now I'm going to start with my first example. This one involved an experiment for hypersonic air-breathing propulsion. It was a fundamental mixing experiment for combustion physics and hypersonics. And it involved a multidisciplinary team of physicists, scientists, measurement scientists, computational experts, experimentalists, and a statistician. That was me. The team leader, I thought, was exemplary in this particular example in his ability to encourage and recognize all of the disciplines. I would say he equalized the disciplines. There was not a producer-consumer relationship. There was a joint effort on that team. As a statistician, we employed myself and other graduate students who I don't see here with me today, DOE and RSM, and those techniques were used in a way to consistently ask the question, what are we going to do with the data when we get it? There's lots of different levels of design of experiments and response surface, but its highest level is knowing what you're going to do with the data before you collect it. And we were able to ask those questions in that team in a non-confrontational way consistently because we were seen as an equal discipline. There was tremendous mutual respect, there was appreciation, and in particular, this was a highly complex problem. So one of the points I'll make later is that in collaboration, most of the time it occurs best in very complex problems. This was a high complexity problem, and I think that tends to humble some of the individual discipline experts when they know that no individual discipline has the answer. This team lead did accurate recognition of all of the contributions, and signs of success were joint publications. So not, in one discipline area or in another, but together, joint publications. And there were years of follow-on collaboration. So the lessons learned for this, as I've talked about, this team lead consistently articulated a common vision and demonstrated mutual respect for every team member. There was common focus around the problem, not around the individual disciplines. This was an example of highly effective statistical collaboration. So on this chart, I've put up a table, and you can take this as a self-exam of where you fall in terms of the way you normally practice. And every project would be different, so we're not collaborators on every project. There are projects we consult on. There are projects that we are cooperative on. But the point of this talk is to strive for that higher level of collaboration. And as you look down the left and the right in the comparison of contrast, I'm just going to point out a few different ones. The third one down, a consultant often is dominated by monologue. They're doing most of the talking, where a collaborator does a large part of listening. There's more dialogue and collaboration. The second to the last one is focusing on the statistical solutions versus a focus on impact. I think there's a danger here, maybe a caution, that we can oftentimes be more focused on good statistical practice rather than on providing solutions. As collaborators, we should keep our eye on the ball. We are not statistical auditors. We're not the defenders of statistical purity. We want to look for the most innovative, creative combination of tools and methods we have available to solve the problem at hand. And that's something I have witnessed in the past where, and I have had to restrain myself when being on a team, and I'll talk about that later. When you see the improper use of statistical methods, you still need to keep focused on what the problem is to solve. So, the motivation to collaborate. Well, it's well known in the literature that collaboration leverages the interdisciplinary expertise. Collaborative teams with multiple disciplines have cognitive diversity, is the term that's used, differences in perspective and in information processing styles. These cognitively diverse teams have the potential usually to outperform other teams, and they provide the faster, better, more innovative solutions. This is well known in industry. This is not a mystery. These are things that have been documented in the literature. I'll just make a comment. At the bottom of a lot of these charts, I have a lot of references, and I'll be happy to provide that complete bibliography to anybody afterwards. But those teams generally have a respect for each other personally, but can challenge each other's disciplines. The term in the literature is that ignorance and argument are useful. The ability to ask and to challenge long-standing opinions and positions in a team that is functioning in a collaborative way tends to reveal unshared information that would not normally come out. Once again, there's a focus here that I want to point out about statistically trained on interdisciplinary teams, is that we have that classic position to be generalists, to be able to ask questions. You know, I tell people that I've worked on everything from soybeans to rocket engines in my career. And that's one of the things that attracted me to statistics, was the fact that the tools and techniques and the methods that we have apply so broadly to many different areas. That's a unique opportunity that we bring on a multidisciplinary team. So I've painted a pretty lofty picture of collaboration, and you're probably sitting there saying, well, but I do statistical practice, right? I mean, there's a joke about statisticians and accountants, something about which one has more personality. You know, this is not my thing, right? This is not what I do as a statistician or statistical practice. So let's take a look at the statistical literature and particular challenges. Well, it's not too pretty. This paper comes, and notice the dates on these papers, by the way. 1988, A Time for Change, from Pfeiffer, Morcourt, and Snee said, you know, our profession is plagued by a lack of public understanding. Anybody here agree with that? You know, many times when I meet people in social settings and they ask, what do you do? I say, I'm a statistician. And the first thing I get is kind of this head turn, like, I'm sorry to hear that. And then, you know, they try to recover a little bit, and they say something like, so you crunch a lot of numbers? And I say, no, I don't. And then they're sort of intrigued and baffled. Well, what do you do? So, well, I help people make decisions in the presence of uncertainty. And they go, wow, that's a redeeming quality. You know, that's not what I expected. But that really is what we do, and I think there's a lack of understanding of that. I think that a lot of this perception issue gets naturally resolved when statisticians and statistical practitioners demonstrate their value on teams. This sort of will clear itself up. They also say in this paper that we need to think of ourselves as scientists who can make a difference. I'm going to talk a little bit in a few minutes about self-perception as well. That is something that I think hinders us, is the way in which, the way of which we enter a project and what we think our role is versus what it could be. So I'll talk a little bit more about that later. From the literature in Bross in 1974, the role of the statistician, scientist, or shoe clerk. Catchy title for an article, right? So I might date myself here, but when you go back, if you remember, you go into a shoe store years ago, there would be all of the displays, and the shoe clerk would come out, and their job was to fit you and to sell you, and they were usually working on commission. I don't know if that example resonates with this group or if it's kind of a generational issue, but let me try to make that more practical. For us, you know, how many times do we go into a situation with our bag of tricks, all of our new statistical tools and methods, maybe the last one that we just learned, and we take and try to apply that and misfit that to a problem at hand. That works fine in the short term, but there are long-term consequences to that. And so what this article points out is that anybody who acts like a shoe clerk will be treated like one. So once again, this promotion of how we think of ourselves and our role. Barato and Zahn 1989, turn this way for the mic, 1989, Promoting Statistics on Becoming Valued and Utilized. Once again, I just want to kind of emphasize these titles. I mean, this is not a talk that I dreamed up. These are things that have been talked about for decades, about the value and recognition of statisticians. They talk about a journeyman statistician. I would like you to read that as a consultant, and you can read that. But they're one that takes the problem, presents it, fits it into convenient statistical solutions, and then passes it on. Monologue. A collaborator who they refer to as a master statistician is one who hears the problem, listens, predominantly listens, from the consumer, or you can think of other subject matter or discipline experts' viewpoint, and discusses the solutions in the consumer's language, speaks their language. You can see the quote at the bottom that they should be a skillful translator, one who never leaves the other subject matter experts feeling like they're lost in a distant land of heteroscedasticity or something, right? So that's from our literature. Another paper from our literature, 1981, a Bill Hunter paper, The Practice of Statistics, the Real World, a time it's come for it. I think that this paper is an excellent paper. I would encourage anybody to read it that wants to be a better collaborator. It really talks about a statistician's role of asking lots of questions and listening. And they have a table in there that I've adapted that I'd like to just briefly talk about. The upper left is the typical role of a statistician, usually thought of as a helper, where they are passive, and the subject matter expert is the one that is active. And that's a very traditional role, and there may be cases, as I've said, not every project is a collaboration, where that is the case. At the bottom right, this is where the statistician is active and the subject matter expert is passive. I like to refer to that as the overzealous PhD student, who's there to obviously solve this problem on the part of it. And that can be okay, but it can be very dangerous, because when that solution doesn't work, the subject matter expert will likely say, well, that was the idea I got from the statistician, right? It's not their idea, it's the idea that was given to me. The upper right corner, the statistician is a colleague, obviously is what I've been talking about. Just another way to present this in this matrix, one that is both mutually respected and a colleague, and in that case, we have the opportunity for effective collaboration and effective statistical engineering. So let me go to my next example. This one involved on-orbit rendezvous and docking, evaluating various LiDAR systems, light and detection ranging systems that were used for the shuttle. Was the test mission, the orbiter. There were 5 orbiter flights, shuttle flights, and 3 measurement systems that flew on those. The test involved docking to the International Space Station. The picture on the right shows that docking ring. And if I had my laser pointer at an angle, I would try to shoot it, but I won't. The missions have been flown over several years, but there was not a coherent, objective analysis, decision-making analysis on which systems were better for our new space architecture, and what were the differences between them. Of course, each one of these systems had their own principal investigators, and of course they thought theirs was the best, clearly. And so an agency-wide team was formed from NASA-wide 5 NASA centers. It involved experts in LiDAR systems and in the particular mission flights that were involved. A statistician was asked to co-lead the team. That was me. These are my stories, of course. And it was a very particular choice, and it initially baffled the experts, I got to tell you. It was an odd sort of welcoming, because obviously they knew the answer. And they didn't really need to analyze the data. They knew the answer, right? But it was a very strategic choice. And I was asked primarily not because of my statistical skills, but also my ability to do interdisciplinary collaboration to co-lead this team. And my ignorance of the subject matter expertise, which I didn't even know what the acronym of LiDAR stood for until I got on the team, enabled me to ask, quote, dumb questions of the experts. And when they answered those, that knowledge got shared across the whole team, because each one of the individual measurement system teams were sort of keeping their information close to the vest and didn't really want to share that. So by me asking those questions in a team setting enabled that cross-sharing of information. It also enabled the fact that they could ask me, quote, dumb statistical questions that they would not have normally asked. So it developed this mutual respect, and it was an excellent example of how the choice of the team lead was critical, to not be a subject matter expert on the answer at hand. I will tell you in this example, I did have to restrain myself from lashing out a couple of times on poorly implemented or executed statistical methods. But I didn't do it because I didn't want to lose the ground or the trust or the respect that we had built in the team. So I did let them run down a few rabbit trails. That was a strategic choice. And at the very beginning of the team, I made it clear that we knew we were going to have to present to NASA headquarters, but that we all were going to present. Each of us was going to have a role to stand up and to present the work that we had done together. So the lessons learned for that, as I've talked about the team lead choice, it took a while to earn that respect. It took a proactive, intentional effort to do that and to demonstrate value. There was a good atmosphere to have technical disagreements without being personally offensive, and it benefited the statistical discipline. The team lead didn't have a particularly good opinion of statisticians before this work, and so it did benefit the discipline overall. So what are some barriers to collaboration? I've already mentioned a few of these in the positive context, but this is just a quick table to talk about what's in the social identity theory literature on barriers. Oftentimes in groups, people identify themselves based on easily identified characteristics. And in multidisciplinary teams, that's often the discipline or the education level. And because of that, everybody wants to have high self-esteem and a high self-worth. And so that naturally, if not coordinated and facilitated, will lead to this idea of misunderstandings of who's more important on this team. Those are all things to be aware of. And on the right, obviously, the desired characteristics are shared identity, mutual trust, all the things that I've talked about so far. All of those misunderstandings eventually lead to defensiveness and breakdown of sharing of communication. So this is my next example. And so I'm going to talk a little bit about the good, bad, and the ugly of collaboration. I've given you two positive examples, and this is to humble myself. This one involved a measurement system that was used to estimate the trajectory of the MSL, Mars Science Laboratory, into the Martian atmosphere. That vehicle was launched in 2011, landed in 2012. Curiosity rover, if you're familiar with that, largest rover, landed on Mars. It was an awesome and cool application. But as I said, we're going to focus a little bit on my stumbles in collaboration. So there was tremendous heritage expertise on this project from the Viking missions and during the shuttle era, and the team was formed without a statistician on the team. Project leadership recognized an opportunity for statistical practice to be infused, and we might say with parental supervision, they assigned a statistician to the team, not a good entrance way to be put on the team. That statistician, who is me, I've already identified myself, a freshly minted PhD, young, well, not quite young, but certainly zealous, and I came onto the team and I was asked to engage. And engage turned out to be a very good description of my activities on this team. It was an engagement. After what seemed like a very cordial sort of introduction, I asked to see the methodological approach for the mathematical modeling that would be used to calibrate the systems and to measure the trajectory into Mars, to reconstruct as it was called. And I found out there was none. Essentially, there was none. So first sign of trouble, all right? I'm here to help with a methodology that doesn't exist. So as I pressed that farther, I was told, well, it's a very complex and difficult problem. I love when people say that to me, you know. It's very complex. That means usually they can't explain it. And so I looked at them and I said, well, I'm very bright. Give me a try. Not the best answer, but, you know, that was okay. And after I sort of figured out what they did know and what they didn't know, I proposed an alternative approach, which was kindly rejected. So then I reproposed that approach as the right way to do it, also not a good choice. And what that led to was a culmination of a meeting with project leadership, about 20 people in the room, where we were going to compare the heritage method and this new proposed alternative right way to do it. I presented mine, an RSM polynomial Taylor series expansion with interaction terms for temperature. It was beautiful. I mean, it was statistically beautiful. It had quality of fit goodness, you know, that was objective in measurement. Anyway, beautiful statistical approach. And on the heritage side, we'll refer to protect names, the old sage presented two transparencies that when overlaid, he said he would use his calibrated eye in order to determine the proper correction for the flight data. Now, silence sort of fell over the room when the calibrated eye came out. You know, it's what do we do after the guy's gone? You know, we need the eye, right? We need to pickle the eye in a jar. You know, there was clearly a concern and from project leadership. And then in the ultimate appeal, he said, we've been doing it this way for 30 years. Anybody ever heard that? So I sat quietly and I looked across the table and I said, you're right. We have been doing it this way for 30 years, and I suggest we all bow our heads in a moment of silence and shame and then figure out how to go forward. Now that was cute, but that was really not a good idea. That's where my quick wit got me. That was a stinging blow. And my boss, who was sitting next to me, who was also part of the 30-year problem, sort of looked at me, you know, what did he just say? So ultimately, I won the argument. RSM was applied, and many of you have heard this talk before, have heard me talk about the positive side of this story. And so it was applied like never before, and it's affected every entry, descent, and landing mission afterwards. I won the battle, but I lost the war. That expert, although not an expert in mathematical modeling, worked diligently to keep me or any statistical practitioner off of teams with some success. You know, I can't go back and run this experiment again. This was a destructive test, and there was no second chance on it. Interestingly enough, as a postscript to the story, I later found out that we were fighting on the wrong battlefield. That, in fact, the project leadership had poorly defined the problem and had overly emphasized the instrument characterization and the measurements, when really what we needed to focus on was the computational models. And there was an effort put on that. And the ultimate uncertainty in reconstructing the entry, descent, and landing onto Mars would have worked fine either way, with the calibrated eye or with my beautiful RSM approach. So my takeaway from that is clearly we didn't have mutual team goals. We had a lot of pride and discipline, defensiveness, and we never developed mutual respect and trust. The biggest takeaway I got from that was this level of collaboration that influences defining the right problem, solving the right problem. We were fighting on the wrong battlefield, and that was because we weren't defining the problem together. So I've talked a lot about collaboration. Hopefully I've motivated you and entertained you at least. There are obviously benefits, individual benefits, team benefits, there's organizational benefits. There's also benefits to our discipline in being better collaborators. And so in conclusion, I would just like to say that collaboration benefits every discipline. I've talked a little bit about statistical focus, but it applies to all disciplines. You know, today's most challenging and complex problems cannot be solved by a single discipline. I said that earlier, and I just want to reiterate that. I hope that I've motivated you to embrace the idea to collaborate, to raise your awareness of what it takes, maybe the missteps that I've shared, that I've done, and to see yourself as a full team member, a first-rate scientist, not a second-rate mathematician, a quote from George Box. And my encouragement to you is I think everybody can become a better collaborator. Some of us have more tendencies than others to do that, but I think we can all be better at it. And from my view, it's unlikely that collaboration will just happen. It requires a proactive approach. And you see my sort of tagline at the bottom that even if you have this mastery of powerful tools, if you're not in the right place, at the right time, at the right table, you're never going to get the opportunity to pull those tools out and have an impact. And so with that, I thank you for your attention.